Hi everyone. Today we'll be viewing the polarization of an LCD screen using just polarized sunglasses and an acrylic sheet. Using the acrylic sheet, we will be able to rotate the polarization of the light being emitted by the LCD so that we can view it with polarized lenses on.
When we first learn about light, it is typically known as a light ray, with a single beam coming out of the light source towards a viewer or an object to reflect off of. But actually, light contains electromagnetic waves that oscillate perpendicularly to the direction of travel. This is known as the wave theory of light. This is also known as unpolarized light, where the angles between the electromagnetic waves is random. We can use what's known as a polarizer, in this case we have a vertical polarizer, to actually change the angle at which the electromagnetic wave is oscillating. Once light passes through this filter, we can allow only the vertical portion of the polarized light to pass through, directing the beam into a specific direction as it travels. Let's take a look at how an LCD works. First, unpolarized light from a backlight is vertically polarized before it passes through the liquid crystal. When no current is applied to the liquid crystal, no polarization rotation occurs on the light. It will then hit a horizontal polarizer where, if there's no polarization rotation induced, it completely blocks the backlight and no light is emitted, resulting in a black screen. However, when current is applied to the liquid crystal, we can induce a 90-degree polarization rotation if the maximum amount of current is produced. Now, the horizontally polarized light can pass through the horizontal polarizer and emit light for us to see. Now looking as to how the experiment works, the horizontally polarized light coming out of the LCD screen will not pass through a vertically polarized lens. With an acrylic sheet placed in between the LCD and the polarized lens, the orientation is important. If the axis of the acrylic sheet is lined up with the axis of the polarized light, we will induce no rotation and we will still have a blocked image. However, as we begin to rotate the acrylic sheet, we will induce polarization rotation on the light and create vertically polarized light that will pass through the lens and allow us to see it. Let's take a look at this in action.
We will begin by viewing our screen through the polarized lenses, and we will notice that we can completely not see the contents of the LCD screen. Now, using the acrylic sheet in between the LCD and the sunglasses, we can begin to see our display's content at varying intensities. This is due to inducing a specific amount of polarization rotation on the LCD's light depending on the axis it lines up with in the acrylic sheet.
Not only is polarization used in sunglasses to reduce glare, but it is also used in 3D glasses for movies in order to create the 3D image.